Hi, today our lesson is about geometry. The lesson is trapezoid. We'll talk about trapezoid and kites. Let's start with trapezoid. The properties of trapezoid. You know, a trapezoid is a quadrilateral made of 4 sides with exactly one pair of lines, parallel lines. So this is a trapezoid A, B, C, D. Only the properties of trapezoid is these two lines, opposite two lines. Only one pair are parallel. Okay? Now, the parallel sides are called bases. So the side AB, which is parallel to DC, we call it base. AB is base and DC is base, but different base. We can call base 1, base 2, or base 1, base 2. It's up to you. Third one is non-parallel sides are called plates. The sides which are not parallel, like AD and BC, we call it plates. Now, there's a special case, we call it isosceles trapezoid, is when the legs are congruent. If these two are congruent, equal and congruent, then we call this an isosceles trapezoid. Now, I think the properties are clear. Let's go to the theorems. Hi again. Now, let's go to the theorems of trapezoids. There are many theorems, but the major one are these 3. If a trapezoid is isosceles, as we said that the legs are congruent, then if the trapezoid is isosceles, then each pair of base angles is congruent. What does it mean? The base angle, if you look to base DC, this is the base angles. You see angle D and angle C. If this is an isosceles trapezoid, then angle D, angle C, the base angles of DC are congruent. Also for base AB, these two angles also for base AB are base angles of AB, where angle A is congruent to angle B. So these base angles are congruent if it is an isosceles. If a trapezoid has one pair congruent base angles, then it is an isosceles. If we know that one pair of one base, not the two, it's one of them, are congruent, then it is an isosceles automatically. Whether these two we know is enough, or we know this two is enough, that these two one base angle are congruent, then it is an isosceles. The last one, if a trapezoid is isosceles, then the diagonals are congruent. What does it mean, the diagonals? You know the diagonals from the previous lesson. If we connect D to D, and if we connect A to C, these are the diagonals of that trapezoid. What we know that this is, if a trapezoid is isosceles, then the diagonals are congruent. Then this diagonal DB is equal to AC. So here AC is congruent to DB. I hope it's clear. Let's go to the next one. Hi again. The last theorem of the trapezoid is a special case. It tells us if you have trapezoid A, C, D, F, and if BE is this line, is the mid-segment of the trapezoid ACDF. Mid-segment, it means if this one is equal to this one, and this one is equal to this one. So, if this is the mid-segment, the middle point of this FD, and the middle point of AC is B, then AF, this is AF, and parallel to BE, it is automatically will be parallel to BE, and CD also will be parallel to BE. Then the segment EB will be equal, or be equal half of AF plus CD. So if we add these bases B1 plus B2 and divided by 2, we get the segment of EB. I hope it's clear. Now, let's have some examples how trapezoid problems will be faced. Let's take first example. This is given an isosceles trapezoid named ABCD It is an isosceles. What is isosceles? That AB is equal to BC. Okay? Well, the measure of angle B is 101 degree. Find the measure of angle B. How much this angle would be? Now, how to solve this one? You know from previous quadrilateral that consecutive angles, angle B plus angle C or angle B plus angle A are always supplementary. So, what do we know? That angle B plus angle C is equal to 180. Well, angle B is 101 plus angle C we don't know equal 180. Then we solve, we find that angle C is equal to 180 minus 101 is 79 degrees. So this angle is 79 degrees. And because it is an isosceles, we know that angle bases of an isosceles triangle are always congruent. Therefore, angle D will be equal to angle C, angle D will be angle C, which is equal to 79 degrees. I hope this example is clear. Let's have now second example about trapezoid. Given an isosceles triangle, isosceles trapezoid ABCD, where the diagonals are DB and AC intersect at E. So he is telling us DB from here to here is 20 and EC equal 15. EC is equal to 5. AE. AE is how much? Now it's obvious that we know the properties of diagonals. If it is an isosceles, they are equal. So AC automatically we know it is equal to DB. So AC equal 15 because AC equal 20 because DB equal 20 as it is given. So AC is 20 minus 15, we know that AE is equal to 5. As simple as that. Thank you very much.